Yes, hello everyone. I think all of you are quite nice, healthy, and staying at home safely and concentrating on your studies properly. And obviously, last two classes we have done the first chapter, second chapter rather, you can say. That one was exponents. And what I feel that one most probably maximum of you have finished. And what I have got a tremendous feedbacks from your side, but not from all the students. Not from all the students. That is not correct. Nowadays almost all of you are actually free. Not almost, everyone are free nowadays. So why you are not going to take your studies nowadays properly and take the advantage of this lockdown period? By the way, this lesson has already been covered up, and today I am going to start square root. But before that, one thing I want to share with you, and that one has come to my mind, that these things are required to discuss with you about the exponents. What is that? What is that? Say as for example, suppose if I am writing here one example here, 2 to the power 3 whole power 2 and 2 to the power 3 power 2. What I want to discuss that what is actually the basic difference? What is the use of this brackets here? But the bracket is not here. What is the difference? I am telling you what is the difference. And you know very well that suppose a to the power, say suppose 5 is there. I have told you that a to the power 5 means a into a into a into a into a for 5 times. You know very well this things. Same things I am going to apply over here also. Say suppose this one, I am actually now consider these things here. 2 to the power 3 whole power 2. 2 to the power 3 whole power 2 means this is that a. And this one is for 2 times, that is 2 to the power 3 into 2 to the power 3. Isn't it? Now, you know very well that the base are equal in case of multiplication, power should be added. So it will be 2 power 3 plus 3, which is equal to 2 power 6. Right? Now let us think about it. What it says, 2 power. And I am finding 3 power 2 is there, means 3 into 3. Am I right? And this one is equal to 2 power 3 into 3 means 9. So you are finding that the result of these two, 2 power 3 whole power 2 is 2 power 6 and 2 power 3 whole power 2 is 2 power 9. Should not think that both of these two are equal. Simple one, brackets is actually changing the value. What I want to say, 2 power 3 whole power 2, this brackets is changing the value. You should not do the same things on this particular. Usually people are doing the same things and you are not getting the correct answers in this particular cases. This implies that this 3 power 2 means this power 2 is only on 3. But here power 2 is means 2 power 3 whole power 2 on 2 power 3 power 2 is there. But this power 2 is only on 3 power 2. This is only the difference. Now, during this particular last session, one of your friend had asked me one question. The question is, this looks a little bit difficult. And she is asking me to solve these questions. 4 power 2, whole power 2, whole power 1, whole power 5 and whole power 6. Okay, how will you find it? This one is equal to 4 power 2 power 2 power 1, and obviously 5 power 6 means what is the value of 5 power 6? 5 into 5 into 5 into 5 into 1, 2, 3, 4, 5 and 6. Am I right? 5 power 6 means 5 into 5 into 5 into 5 into and such is a big value will come. Even myself also taking some hesitations for doing this particular calculation does not imply that it is quite impossible to find out. Some value will come. I am telling you what will be the value. The value is coming as 15625. I have taken these calculations by using my calculators. And suppose this value is nothing but, say suppose this value, I am not going to write this value here, is a big value. In spite of that, I am going to write here m. Correct? So it will be equal to 5 power 6. I have written this here. And 5 power 6 is m. Say suppose. Now I am finding 1 power something is there. So 1 power this value, if it is coming 15625, then what will happen? 1 into 1 into 1 into 1 into this many number of times. If you are going to multiply 1 for 1000 times or 2000 times or whatever it is, the result ultimately will come 1. Am I right? So therefore this one will be equal to 4 power 2 whole power 2, and this one will be nothing but 1 only. Correct? And this one will be equal to 4 power 2, and 2 to the power 1 is nothing but 2. Correct? And 2 power 2, this 2 power 2, this 2 power 2, I am talking about only this 2 power 2. This 2 power 2 is nothing but 2 power 2, means it is 4. That is 4 power 4. Now this 4 you can write as 2 power 2 whole power 4. Now it is whole power 4. Because 4 is, this power 4 is on 4. And this 4 I am writing as 2 power 2. Correct? Isn't it? So in this case you can say, this will be, now power going to multiply. This one is equal to 2 power 8. No need to find the value of this, you can put the answers here only. Or if you want, you can find the value. I think it is clear. I think it is clear. So this type of questions you will find in many of the books. Right? Now let us start the new lesson. Okay, you should copy it. Now let us start a new lesson. That one is square root. From today onwards, I am not going to give you that 30 or 20 minutes video clips. Only one exercise each day. It will take hardly 10 minutes time. In one day, I am not going to consider multiple exercises. Little bit slow motions I will move. By the way, now it is square root. Square and square root. Square and square root. This square and square root, the name says that this square root basically consists of two lessons. One is square, other is square root. First of all, let us think about the square. Suppose any number is there, and if we want to check that if it is a perfect square or not. Say as for example 441. I am taking one question from your book, from exercise 3A. It is questions number 1. And they are asking you that by using prime factorizations method, find which of the following numbers are perfect squares. So you will have to check, you have to show. Directly you should not write that sir it is not a perfect square or it is a perfect square. For that you will have to give the reason, and that reason should be in the form of prime factorizations method. Yes, in the advanced stages you will find many method is there. Here they are asking you to check that if it is perfect square or not by using prime factorizations. So what we have to do, 441 you have to write here. Now prime factorization means you have to divide this number by the smallest prime number. Prime number means it is 2, 3, 5, 7 and then 11 etc. etc. The number which is not divisible by any number other than itself. The smallest prime number is 2. And this is a very unique number. What is the uniqueness of this number? This is only the prime number which is even. By the way, so smallest, you have to start these divisions by the smallest prime number. Say suppose the first prime number is 3. I am finding 4 plus 4, 8 plus 1 is 9. 9 is divisible by 3, so definitely this number should be divisible by 3. Let's say 3 1s are 3, 1 4 3 4s are 12, 2 1 3 7s are 21. Now again it is divisible by 3 4s are 12, 2 7 3 9s are 27. Now this number again it is divisible by 7 only, 7 7s are 49. So 441 you can write as 3 square and 7 square. So I am finding that this number is nothing but 3 square and 7 square. Two prime numbers are there, and on each prime number square sign is there. Square sign is there. So therefore this is a perfect square. So therefore 441 is a perfect square. Fine. One more question I am going to consider here. Suppose the question is a little bit bigger questions I am going to consider now here. Say suppose double one number 2. Number 3 rather you can say. Number 3. The question is double 1 0 to 5. Double 1 0 to 5. You have to check this number if it is a perfect square or not. In that case, again the same things we'll have to do, double 1 0 2 5. Divide this number first of all with a smallest prime number. I think this will be nothing but 5. 5 2s are 10, 1 0, 5 2s are 10, 0, 5 5s are 25. Again it is possible to divide by 5. 5 4s are 20, 2 0 5 4s are 21, 441. And 441 it is coming here, last questions. So this one is divisible by 3. I am finding, I am going to cheat here. It is 147. And this one is 3 again. It is 49. And this is 7. So I am finding further it's not possible to divide. So therefore you can say double 1 0 to 5. You can write as 5 square, 3 square and 7 square. 5 square, 3 square and 7 square. So therefore double 1 0 to 5 is a perfect square. No, it is not necessary that always in every cases power 2 will come. No, it is not required. Because I have selected randomly the questions. So randomly I thought that most probably power 2 will not come. One questions I am going to select that when the power 2 will not come in on every prime numbers. Say suppose one more examples I am going to consider here. The question is, suppose suppose 6292. 6292. One example questions. We'll have to check that if it is perfect square or not. How will you do? Again, same method. First of all, divide this one by 2. 2 3s are 6. 2 1s are 2. 4 2s are 8, 1, 6, 2 6 are 12. Then again by 2, 2 1s are 2, 1, 1, 10. 5 2s are 10, 1 4 7, 2 3s are 6. Then is it possible to divide? For 7 3 10, 10 plus 5 15, 1 16, 3 by 3 it is not possible to divide. 5 plus 7 plus 1, by 11 it is possible to divide. By 11 it is possible to divide. 11 ones are 11, 4 7, 11 fours are 44, 11 threes are. Again it is possible to divide by 11. 11 ones are 11, 11 threes are, that's all. So 6 2, 9 2, I am finding this is in pair 2 square into 11 square, and here it is only 30. So therefore 6 2, 9 2 is not a perfect square. Okay? Right? Now, let us proceed. Now let us proceed. Now let us think about this number. 6 2, 9 2. Again this number I have considered. And this one is equal to 2 square into 11 square into 30. So I am finding that 6292 is not a perfect square because on 13 power 2 is not there. Suppose in this particular question, if they are asking, it is a different slot of questions. You will find that one group of questions it will be given to you. That check if it is a perfect square or not. If it is not a perfect square, make it a perfect square by multiplying the smallest number. Here I am finding that 13 is actually odd man out. It should be square. So to make this number a perfect square, then naturally 13 squares should come. Then how much is required to multiply to make this number as a perfect square? That one is only a 13. I think it is clear. Suppose if we are going to multiply this one with 30, then it will going to be a perfect square. So what I am going to do, I am going to write here how much is required to multiply to make this number as a perfect square. What I am going to write here, therefore 13 is required to multiply with 6292 to make the number a perfect square. Yes, obviously these factors you will have to find by using this method. That's why I have not rubbed this one. My tendency is, because all the math students having this type of tendencies, that doing the work in a least possible effort. So being a math teacher also, I am doing the same things over here. After solving these questions, immediately these things been strike to my mind that on this particular topic, why should we not create these particular things? So these questions may possible to create that how much number is required to multiply to make this number a perfect square, because on 13 I am finding it is not a perfect square. 13 is not a perfect, 13 power 2 is not there, only 13 power 1 is there, one deficiency of 13 is there. So therefore to fulfill that deficiency, I am going to multiply a 13 with that number to make this number a perfect square. So 6292 will become a perfect square if we are going to multiply this number only by 30. This is the least number. I think it is clear. Now suppose if they are going to ask, then what will be the number if you are going to multiply this one by 13, then just multiply this one by 13 and find the number. Okay, this is one phase. Now the second phase of it is that how much is going to, this is not a perfect square, you know very well. In spite of, suppose they are asking that how much is required to multiply, in spite of if they are going to ask how much is required to divide to make it a perfect square. So in that case I am finding 13 is the odd man out, kick it out. How it will go out? If we are going to divide this number, if I am going to divide this number by 13, 13 will cancel. So how much is required to divide to make the number a perfect square? 13 is required to divide to make the perfect square. This is one slot, and the second slot will be 13 is required to divide 6292 to make the number a perfect square. I think it is clear. If I am going to divide this number by 13, what will be the number? 2 square and 11 square only will left. That is 4 into 121. 4 into 121 will be how much? 4 into 121 is 4 ones are 4, 2s are 8, 484. So 6292, below of it 484 only is the number which is a perfect square. Is it clear? Anyway, so I have discussed here two different type of questions by taking one question. Fine. So rather you can say I have solved three different type of questions. One question, if it is perfect square or not. If it is not a perfect square, second question, if it is not a perfect square, how much is required to multiply? This method. And if it is not a perfect square, how much is required to divide? This method. This way you can solve these three type of question. Now let us go for another set of question. The question is, show that, question number 2, you can say that question number 3 and question number 5, question number 3 and question number 4 already I have discussed by taking questions from question number 1. So 3 and 4 I am not going to discuss now. Now I am going to discuss about the question number 4. Question number 4 is, show that each of the following number is a perfect square in each case, and in each case find the number whose square it is. The meaning of the question is, they have already told 1, 2, 2, 5. 1, 2, 2, 5. They are going to say that this is a perfect square. 25 is a perfect square, say as for example. Now suppose if I am asking you 25 is a perfect square, whose square it is? 5 square. Same thing, 1, 2, 2, 5 is a perfect square. Suppose I am asking you whose square it is? Yes, like the 25 can't give the answer. In that case you will have to go through the solutions. 1, 2, 2, 5. Take the prime factorization method. 5 2s are 10, 2, 2, 5 4s are 20, 5 5s are 25. Again by 5. Again by 5. 5 4s are 20, 4 5 9s are 45. And this is 7 into 7. So therefore 1, 2, 2, 5 you can write as 5 square and 7 square. Really we are finding that it is a perfect square, am I right? Because on 5 also square is there, on 7 also square is there. So therefore it is a perfect square. And this one you can write as 5 into 7 whole square by the rule of exponents. and this one is equal to 5 7s are 35 square. So 1225 you can say is the square of 35. So therefore 1225 is the square of 35. Similarly, you can solve the other question also. Is it required to solve one question? Okay, I am going to solve one question also here. Say suppose question number 3, fifth one. Question number 2 is fifth one. Question number 2 is fifth one. Eight two eight one. Yes, they are saying they are actually claims that this is a perfect square. Then let us see if their claim is correct or not. Okay, it is not divisible by 9 and 3. So 8281. It is not divisible by 3. I think with 7. Wait a minute, let me verify. Seven. 7 ones are 7. 1, 2, 12. 7 ones are 7 again. 58. Yes. Now again divide this one by 7. 7 ones are 7. 7 9 is 63. Then 13. So 8281 you can write as 7 square into 13 square. So I am finding that on these two prime numbers square sign is there. So therefore it is a perfect square. What they are claiming that is correct. Into 13 whole square, which is equal to 91 square. So therefore 8281 is the square of 91. You may verify if suppose some calculation mistake will be there, then you may adjust that one, because it is not simple classes, it is online classes, so you are much far from me. So in that case, suppose if you are finding that some calculation mistake if it will come, then I think that much maturity you are having that you can adjust that one. So you can say that question number 1, question number 2, question number 3 and question number 4 we have done. Now about question number 5 and 6, only 6 questions it is there in this particular chapter. About this particular 5 and 6 questions, I want to say one thing, that these questions should not come here. It should come in the later exercises. So for the time being, don't try to solve this question number 5 or question number 6. Right? That one I will discuss later on. So this is about square root for the time being. You have to wait for the second classes, next classes for the next exercises.